Section 1.5, we're focusing on solving inequalities. So that's pretty much your less than or equal to, greater than or equal to. So those symbols sitting right there. Of course, we're going to be looking at how to solve them, how to graph them, and then a new type of notation that you're going to be using definitely in Algebra 2 honors, but also in pre-calc honors and in calculus as you start moving into the advanced level mathematics, and that's called interval notation. But the plus side with inequalities, when we're solving inequalities, we're more or less following the same steps that you would use to solve an equation. If you can solve an equation, you can solve an inequality. There are a few things that are different. After you finish solving the inequality, you graph the answer on a number line, which I've put the steps for graphing on the number line. We'll practice that in a second. If you multiply or divide by a negative number, you reverse the inequality sign. So less than will become greater than, as an example. Again, the new part is putting your answer in interval notation. The interval notation uses parentheses and brackets. And interval notation will be a little bit clearer after you do the graph. So we'll practice doing interval notation. And then the last thing that's here is more so a hint or key thing more than anything else. You want to try to solve your inequality so that the variables end up on the left-hand side. More or less because it just makes it easy for you to interpret, easy to solve the problem. I mean, if you want to put all your variables on the right-hand side, be my guest. But most of the time, if you put them on the left-hand side, it makes it easier to solve. So this is essentially the lay of the land of what we're going to be doing today, practicing solving inequalities. So let's go ahead and jump right on in. So blow this up just a little bit so that we got problems 1 and 2 on the page. So, problem 1, we're going to solve, graph, and represent in interval notation 5r plus 9 less than negative 26. So, first order of business, solve the problem as if it was an equation. So, 5r plus 9 less than negative 26. So, you subtract 9 on both sides. So that gives you 5r less than negative 35. Divide both sides by 5. You get r is less than negative 7. So, again, the intermediary steps in between the minus 9 on both sides, dividing by 5, you don't necessarily have to show those. The steps that I wrote in blue are more than sufficient. So, this is our solving. Now we're going to graph it. So, for the graph, draw your number line, put 0 in the middle. Negative 7 is on the left side of 0. You don't have to count all the tick marks. 0 in the number is more than fine. Since it's a less than symbol, put an open circle. And And less than would mean shade to the left. So that's your graph. So now we work with interval notation. So interval notation is just another way to represent the solution. So notice that you have a graph going all the way to the left forever, all the way into -7. So interval notation is how you would read the problem going from left to right. So if you were to interpret this number line going from left to right, you have all the negative numbers out to forever, which we represent as negative infinity. So you're coming from negative infinity all the way to -7. So now we either put a parentheses or a bracket. It's very easy to tell what gets what. For interval notation, if you have a less than, a greater than, or an infinity, you always use parentheses. The reason why you use parentheses is because the number, either the number is not included or you don't know where it stops. Infinity doesn't stop. So that's why infinity is parentheses. -7 is not included. So that's why it gets parentheses. So that's your interval notation. You're just representing without a graph what the answer is. Less than, greater than, and infinity uses the parentheses. Less than or equal to, and greater than or equal to would use a bracket. Brackets mean the number is included. So we solved it, we put it in a graph, and we put it in interval notation. So those are the three representations. So I've said a lot. Let me pause for a second. Any questions that you have or anything that's not necessarily clear? Check the chat, don't see anything. No one used their hand raised hand icon, so it looks like we're good to go. We can move. Alright, so we'll do it again with example number 2. Example 2. So we have 12 less than or equal to -4 parentheses 3c minus 6. So again, we're solving the problem the exact same way that we would solve an equation. Make this a little bit bigger. We're solving it the exact same way we solve an equation. So that means we distribute this -4. And then we keep solving from there. Subtract 24 to the left-hand side. And then divide both sides by -12. Now keep in mind, we're getting ready to divide by a negative number. So when you divide by a negative number, that causes the sign to flip. So less than or equal to will now become greater than or equal to. So you have 1 is greater than or equal to C. 1 is greater than or equal to c. Now, if you prefer to have your variable on the left-hand side, you can put the variable on the left-hand side, but that means you got to turn the inequality sign around. So 1 greater than or equal to c is the same thing as c less than or equal to 1. So they mean the same thing. Again, that's more personal preference. It doesn't matter to me which way you leave it as long as you interpret the inequality correctly. Any questions so far? So there's our solve. Now we graph it. Put your 0, put your 1. So less than or equal to, I'm using the one that has the variable coming first. Less than or equal to, you put a closed circle on the 1. And then less than or equal to means you shade to the left. You shade to the left. So there's your graph. Interval notation is shading to the left, so that's negative infinity to 1. Remember, negative infinity always gets parentheses, but 1 is a closed circle. It's less than or equal to, so the 1 gets a bracket. Bracket indicates that the number is included. The bracket indicates the number is an answer. So there's your 3 representations. So questions, problem number 2. So open circle and closed circle depends on the sign. So if you have less than or greater than, that gets the open circle. Less than or equal to or greater than or equal to closed circle. So if you see the line underneath, it's giving a closed circle. Good question. Any other questions sitting out there? See something in the chat. Let me make sure that I put that out. All right, example 3. Example 3, we can still solve this with variables on both sides. So there's no parentheses, so there's no distributing. No combining like terms on either side, so we can start with moving the variables. So -4, -17, I always prefer to move the smaller variable. So I'm going to move 17z on both sides. -25 plus 13z is greater than 66. So now this is more or less a 2-step equation, so inequality. Add 25. 13z is less than or equal to 91. Divide both sides by 13. Z is greater than or equal to 7. So there's our algebraic representation. So we've got algebra. Now we do our graph. 0, 7, greater than or equal to is a closed circle. And since it's greater than or equal to, we will shade to the right. So now we do the interval. So remember, interval notation is reading the problem from left to right. So if I read this problem from left to right, I'm starting from 7 and going to the right forever. So that would mean 7, comma, positive infinity. You don't have to put the plus, but positive infinity. 7 gets the bracket because it was greater than or equal to. Infinity always gets parentheses. You never put a bracket on infinity. If you put a bracket on infinity, then you're saying that you know where infinity stops.
Mr. Lowe.
Yes, go ahead.
How did you get to every consider?
Nope. Thank you so much. Trying to do this without erasing anything. Oh well. Thank you so much for that. That should be regular. That should be open circle. Which would make this parentheses 7 positive infinity. Thank you so much. So yes, both of them should be parentheses. Like I said, Mr. Lowe's not perfect. Questions 1, 2, or 3?
I have a question.
Go ahead.
How do you decide like which number goes on one side of the comma when you do the notation?
So when you do the notation, look at your graph and then read the graph going from left to right. So let's go back to problems 1 and 2. It was shaded all the way on the left, and it was going that way forever. That means you're starting with negative infinity, and you're going to the number. So that means the number would have come second. Problem 3, it was in reverse. The number started the graph, and you were shading all the way over to the right. So then the number goes first, and then infinity comes after it. So it depends on how the graph was done. If the shading is first and the number is last, then infinity would come first and the number would go last. If it's reversed, then it would be reversed. So again, the way I've seen it, some students will solve it and then do interval notation immediately after it. I've always recommended do the graph first because it makes interval notation that much easier to see. But that's more personal preference. Excellent question there. Thank you for that. Any other questions before we look at example 4? All right, then let's mosey on to example 4. So we have n greater than or equal to negative 3n minus 15 over 8. So the first thing we're going to want to do is get rid of this fraction. First thing you're going to do is get rid of the fraction. So we can take the inequality. Again, don't feel that you have to rewrite the problem. I'm only doing it for explanation purposes. Multiply both sides by 8. So again, we're getting rid of the fraction. 8 times n is 8n. Greater than or equal to. The 8's cancel out. So you're left with negative 3n minus 15. The 8 here and the 8 there will drop out. Now, we still have variables on both sides, so we still have to take care of that. Add 3n to both sides. So you have 11n greater than or equal to negative 15. Divide both sides by 11. N is greater than or equal to negative 15 over 11. And since I know that that's a decimal that doesn't end, I'm going to leave it as a fraction. So the question might be out there, why didn't I flip the sign? The reason why you don't flip the sign is because the number that you divided by was not negative. The number next to the variable wasn't negative. That's why you don't flip the sign. So that's your solved answer. Now we can do our graph. So negative 15 over 11, throw that on the left-hand side. This is greater than or equal to, put open circle, closed circle. Greater than or equal to means you shade to the right. So there's your graph. So for interval notation, since the number is coming first before the shading, the number goes first, and then infinity will come after it. Parentheses always on infinity. Since it's greater than or equal to, put a bracket. So there's your solve, there's your graph, there's your error. Any questions with problem 4? Any areas of clarification? Saying none, hearing none. All right, let's practice word problem. Problem 5. Alex is having his car worked on at a shop, charging $85 per hour for repair. The parts for his car cost $210. If he has $700 available to get his car fixed, what is the maximum number of whole number hours that Alex can have his car fixed? So Alex took his car to the shop, got to get it fixed. So most shops, they're going to charge you for your parts plus your labor. parts plus labor equals your total. So for parts, $210, and then labor is $85 per hour. You don't know how many hours that is, so 85 times H. He has $700 available. So that means he can spend less than 700. He can spend exactly 700, but he can't go over 700 because he doesn't have it. So $700 available based off of this problem means less than or equal to 700. So let's pause for a second. Any questions on the setup? Any questions on the setup? Okay, John, you're good. All right, let's go ahead and solve this out. So if we subtract 210 on both sides, you're left with 85H less than or equal to 490. Divide both sides by 85. You get H is less than or equal to 5.7647. So that's more or less your exact answer, but think about what they asked you in the problem. What is the maximum number of whole number hours? So think about it. Whole number hours is whole number. 5, 6, 7. So 5.76 is between 5 and 6. So that means if he works on it for 5 hours, I'll be less than $700. If I ask them, hey, can I work on this for 6 hours? If I work on that for 6 hours, that's going to be $720. I don't have $720. I only have $700. So your answer is H has to be less than or equal to 5 hours. So the maximum number of hours that he can have his car worked on is 5. Any questions on how we arrive with 5 instead of the 5.76 number? All right, then let's knock out one more word problem before we finish up. Probably something that you try to figure out on a daily basis with regards to your grades. On our first 3 tests, Grace scored at 87, 92, and 85. What must she earn on the 4th test to obtain an average of at least a 90? So, first 3 tests, 87, 92, 85. She wants an average of at least a 90. So, of course, average, add up all the tests, divide by however many tests you had. We have 87 plus 92 plus 85 plus whatever that 4th test is going to be, divided by 4. There's 4 tests now. you want this number to at least means greater than or equal to. You either want a 90 or you want a higher than a 90. So now we got a setup. Questions before we continue? All right, now let's go ahead and solve this out. First off, so you can combine like terms first, or you can get rid of the fraction first. It doesn't really make much of a difference. Or you can take care of both of them at once. Multiply times 4. So the 4s will cancel out. And 87 plus 92 plus 85 is 264. Plus t is greater than or equal to 360. So just to clarify, multiply both sides by 4 and added those up. Then subtract 264 on both sides. So t has to be greater than, I want to say that that's 96. 96. So if she wants to move that average back to a 90, she's got to get a 96 on this test. 96 or higher than that. So you got to make it happen and make it work. Questions on example 6? All right. Then example 7, I'll work it out when I post this to Google Classroom, but we'll discuss that one tomorrow to finish off this notes page.